In this lecture, we are simple discuss about the hyperparameter tuning, or simple another language we called to maintain the tackle between bias and variance. So in Naïve we see that so simple. First, see high variance means what? In logistic regressions we have seen this, in a linear regression, in a, and also in the when also just logistic regression, support vector machine, linear regressions, everywhere we have these two things occurs: bias and variance. And to maintain this where between these two things is the main thing. So how to maintain these two things? By this just simple tuning the our hyperparameters. Okay, so high bias means what? High bias means simply it is our underfit model. Our model is simple underfit. Okay, or high variance means what? Simple, our model is overfit model. Okay, and now in this Naïve based technique, in this simple Naïve based classifier techniques, we are handle these two things. So we see when we have just learned the hyperparameter tuning. Hyperparameter tuning means Laplace smoothing. When we have seen in Laplace smoothing classes that alpha is simple. We see that alpha is simple our hyperparameter. Alpha in Laplace smoothing. So to increase the value of alpha and to decrease the value of alpha, that is we have to tackle between these two things, that is bias and variance. Okay, so the another language, if you just remember, I have also in previous lecture also I'm tell that. So high variance means what? High variance means small changes in our training data, so our model is changed dramatically. Okay, simple, its definitions means, if you just write its definitions as you will. So small training data change that will imply the result our model changed dramatically. We have seen this thing, small changes. If we just small change our training data, then total model is changed. So this thing is not occur. And another language, bias means what? Bias means we have included more and more outliers here. Okay, means our error is so much that it is total. If we just change our data sets, that it is not totally impact our model. Okay, these things also these things also bad. And by variance things also means we have just overfit our model, overtrained our model. And just underfit means what? We have included more and more bias. Okay, so we have to tackle the things between them. This is the main thing. Now let's see one by one. So here alpha is actually, or in Laplace smoothing we have seen that alpha is actually the hyperparameter. So first let's take, if we just choose the alpha is equals to 0, and after that we have just increased the value of alpha. Let's see what happened to both the cases. So first let's see case 1. First in case, let's see, we have chosen alpha is equals to 0. What happened in these cases? If we choose alpha is equals to 0, then what will be our probability? Actually we have to interest to calculate this probability of A given data point for a probability of a data point for given class level y is equals to 1, we are interested to calculate it. These we call the likelihood probability. Actually, we have calculated two type of probability. One is likelihood probability and another is a class prior probability. So how to calculate this probability? This means we have in denominator, we have denominator number of training data points with class level 1. So number one, just first, just what is means this probability? This means in denominator we have the number of data points that belongs in class level 1. So this thing means train points with our class level y is equals to 1, and in numerator it will be our training points, training data points that occurs wi occurs as well as it occurs in class 1. Okay, so we have just also many times we have seen this probability. Okay, so let's take our data point is, so let's take in our training data, our data point is suppose 20k, suppose 20,000 our data point, and in this 20,000 our positive data point is 10,000 and the negative data point is as well 10,000. Let's see. So positive data point is 10,000 as well negative data point is 10,000. So now what will be the value of this now? So what will be this value? So now suppose let's take we have few point. Suppose let's take we have few points in this set. Suppose in train data we have wi occurs only. Suppose in just if you using the text classifications, there have many text, there have in English language there have many text, so just occur few times in a sentence. Okay, just occur only few times. So if let's take wi such kind of word that's occur only few times in our whole data sets. Okay, suppose let's take for our class 1 this wi word occurs only 2 times. Okay, of how much word we have in training data, that is positive word in our total whole training data we have 10,000 total word. Okay, so only this means, just write down, don't be confusion, this means only 2 times occur, only 2 times occurs in class y is equals to 1, and this thing means positive data points in training set. Okay, now the thing is that, now the main thing is that so now what will be the probability, this probability, what will be this probability? Just see this one, what will be now this probability? So now this probability will be very small, because we have only 2 times occur. Just for numerator we have only 2 times occur, so very small, this probability value will be very small. Okay, so in these situations we have faced one problem. So what is this problem? Because so this problem is since, so we see that wi, actually wi occurs only few times. Actually wi occurs only few times if we just change this wi in our training data sets. So this model will dramatically change. So let's see. So since wi occurred only in 2 out of 20,000 data points, out of I think 20,000. Out of 20,000 cases, only 2 times it occurs. So in these 20,000, so we have 10k positive points and 10k negative plus. So by small changes, we make a small change in my training data. Means what? If we change small change means what? If we just simply remove this word, if we just, since it is occurs only few times, we may not be interested of this word. If we just remove this word from our training data sets, then what happens? If we remove these two words, if we remove the two text, means this wi, not text, two words, it will be better. Two words, two words from different, or another language you may call both are the same, another language for. If we remove the two text, that is xis, and each xis contains what? If we just remove these two text, that contains that content is wi. Okay, if we just read, then what happened? So then the probability of this one, then the probability of wi for a given class level 1 will be what? This will be 0. Now in previously we have seen this probability will be this one, but if we remove this probability, now I'm going to 0. Okay, from this probability we got this probability is equals to 0. Okay, 0 means what? If we got this probability is 0, then the total model is changed, because our actual, at the end of the day we have to calculate this probability. So we have to calculate this probability of a given class level for a word, for a given text. For a suppose given text means for a given text, suppose text query text, we are interested to calculate it this word, this query text. If in query text this word happen, then this total probability will be 0. So we are not interested. So this at that time, so the total model will be changed. So this is a bad situation. This is a very bad situation. Okay. Now in case 1, we will see that, just if you just summarize this thing, if our alpha is equals to 0, then small change in our training data, so it results in large. Okay, this means what? This means we have large shells means our in the model. This means what? This means we have make a high variance model, and this implies means we have make a overfit model. These both are the same thing. We are making a overfitting model. We are going to make a overfitting. Okay, I think if we choose simple alpha is equals to 0, then how our model affects and how its behavior changes dramatically. And in natural cases, if you just see the raw text data for a blog or for a website or for a newspaper, everything there have many words which occurs only few times. So if we for our text pre-processing purpose, if we just remove this word, So simple, this thing change our model dramatically. Okay, so this situation is very. So now in case 2, let's see. In case 1, we have seen alpha is equals to 0. Let's see in case 2. Let's now take alpha is equals to very large. Let's see. Let's take. Let's see what happened. Suppose we are in case 2 take case 2. In case 2, let's alpha is very large. And suppose consider alpha is equals to 10,000. Suppose let's say alpha is equals to or 10,000, 1 lakhs. 1 lakhs, I think it is okay for 1. Okay, 1 lakhs. I'm taking the alpha is equals to 1 lakhs. So what happened in this case? So now the probability will be now in this case wi by for if we just calculated this likelihood probability, so what will be the value? So now this value will be 2 number of 2 wi is number of 2 only occurs of our positive class point is 10k, only positive 10k, and here alpha is what? Here alpha is 1 lakh. And suppose let's take our wi is we have taken the binary classifier. So in such cases wi take a 2 value 0 or it will take 1. So let's take our k is equals to 2. So if we take k is equals to 2, so what will be now this will be 2 lakhs. Alpha into k means that 2 lakhs. Okay. So now if you just calculate it, this is approximate equals. This is approximate equals. And this probability, and if we just applying the this Laplace smoothing, just here we apply simply the Laplace smoothing. If we see that in Laplace smoothing videos, we have seen that we are applying the Laplace smoothing all for all words, not for all on that word that will occur on few times, or that word that will not occur in our training set, that only occur in our query set. So this not thing we are happening in Laplace. We are applying all the words. So for all wi what happened? So for all wi, now this value will be probability of wi for given class level 1, as well as this same thing will occur also for negative classes. We just consider the negative class, this thing. So these two probabilities now. Okay. If this two likelihood, this means what? This thing is actual likelihood probability. If this two likelihood probability is equivalent to half, this means what? This means that our probability of our probability of w for a given class level y is equals to 1 for a query data point xq. Suppose let's our query text is equals to xq. Suppose let xq is equals to xq query text, and its approximate equals to half. So in such scenario, you have seen that we cannot classify properly, because for this query text we have find that, because we have to, for counting the query text, we have multiplied this likelihood probability. So after multiplying this probability, we also find that this probability value will be approximately equals to half. So in such cases, we cannot classify query text which class 1 or it will be in class 0. So in such situations, we call that what this model is a underfit model. This model is a underfit model. Means what? We have our model contains a high bias model. That's high bias. So we see these situations is comparable with our KNN model, KNN thing. Okay, KNN. So just if you remember the KNN, in KNN, what we will see? Just if you remember the KNN. In KNN, we see that K is our hyperparameter. Here K is our hyperparameter. Hyperparameter. If we choose A is equals to N, then what? If we choose simple thing, if we choose the K is equals to N, then our in KNN, this model is our underfit model, means high bias model. We have seen this thing. These underfit models, or this model contains high bias. Okay, high bias model. So if in KNN we see that if we have, suppose let's take our data points is N1 is our positive data point, and N2 let's take our negative data. If our N1, suppose let's take N1 greater than N2, let's take. So if we just taken a query point Q, so for this query point we've seen that for all the cases, for all the query points, so we cannot classify properly. So all the query for all query point, these classifications will happen the positive class. First, which class data points is greater, most larger? In which class the data point is most larger? So here we have taken our positive class's data point is larger than the negative class. So always this class will be, our query class will be positive. We have seen this thing in KNN. Because of these underfitting situations, the same thing also happen in this naive base. Okay, so let how it is naive base as well. In naive base also, this thing also in a naive base. In naive base, what we are calculating? We are interested to calculate this thing. Hence, probability of y is equals to 1 for a given query point. Suppose let's take our query point is this. This is our query text. Okay, let's take. So what we are calculating? We are calculating the prior probability of class 1, and as well we are interested to calculating the likelihood probability. So here we will want the probability of our likelihood class 2 1. We have calculated this probability, and as well if we just consider the binary classifier, we are also calculated this probability. Just again and again writing this. Let's see, it will be 5. We have calculated these two probabilities, and we have seen that if we have a k, if our alpha is equals to large, then these two things, approximately these two things for all the word wi is these two values which approximates equals to half, means these two values are equal. These two values, if a's terms is approximate equals to half, so these two values will be equal because of these values approximate to half. Now the main thing is here. Now the main thing occurs here. These two terms. Okay, these two terms. So the if you just remember how we calculated, suppose let's take an example. Suppose let's say n is our total training data. Let's take, and in this n1 point we have n1 positive number of data set. N1 point is positive and n2 point that is negative. Okay, so total in n1 data training data, our n1 number of points are from class 1 positive class and n2 number of points for negative. So here what will be the probability? So this probability will be now n1 by n total number of, and this probability will be n2 by n2 by n. So let's if our n1 greater than n, if our positive data points of our positive class greater than the point of our negative class, then what happened? Then if you see, this probability will be the more than this one, and these things are equal. This probability is approximately equal. These two probabilities are approximately equal. But the main thing is here. So the main thing is the probability of y1. Because of this, probability of y1 now is greater than, much larger than probability of y to 0. This thing will get a larger probability. So we see that for any query text, our class will be positive class, because not only positive class. So which data, in which classes data point is larger? If our negative classes data n2 is larger, then our query text class will be what? Negative. Okay, I think the situations you will understand clearly. So the same thing occur also in KNN. If we have a bias model, then the after in the query, the effect of the query text as appears so much, because the query text always giving the output as the number in which classes our data point is larger. These class levels always give our output of the query point. So we've seen this thing in KNN as well as we have seen this thing in Naïve base. Okay. So in case to what, see, we just conclude this thing in case to what we have seen. If our alpha is very large, we have seen that our models makes an underfit model. Means another language, our model contains high bias. Okay. In case 1, just you've seen this thing in case 2. And in case 1, we have seen if alpha is equals to 0, then we have make an overfit model. That implies we have make a model that contains high variance. Okay, now the main question is, you tell, like, if we take alpha is equals to 0, then our model is overfit. Although if we take alpha is equals to very large, the model is underfit. But how we will choose the proper alpha between these two values, between these two? Okay. So this thing as same as our KNN. Now the questions is that, now the main questions occur is, so how to find the right alpha? This is the main questions. How to find the right alpha questions. So simple, as usual, KNN, how we find it? If you just remember the KNN, we find the right alpha. In KNN, what is the hyperparameter? K. Here alpha is a hyperparameter. KNN, we choose the right K by simple using the simple cross validations. Simple cross validations or tenfold cross validations. The same things also here. So the same thing, we have to choose the right K here also. here also we choose right alpha by simple cross validation, or by simple using tenfold cross validation. The same trick is applicable. Okay, so we see, so if knn in knn and also in Naïve, in knn hyperparameter is a, and here it is our hyperparameter knn. So we see that in knn hyperparameter is k, the same thing work as well for alpha in Naïve. So to tackle the to handle the OR between bias and and variance, we have to choose the right thing as well as right to handle it. If we choose Naïve-based algorithm, then we have to choose right alpha. Then if we choose KNN algorithm, then we have to choose. I think this concept is clear. By how the hyperparameters importance in based. Okay. So total just by simple using, I think I have discussed all the things, all the primary concept from a primary example. You and your idea will be clear. If any interviewers ask any questions from this is very base, I think then you can understand. When the thing is, you can how you'll understand that how to interpret this model to real world. Okay, just not reading this model, just not write some mathematical equations and apply. It is not the main thing. Main thing is how to interpret it. If we just change the small thing, if we have to just if you implement into this another way, how you can visualize this thing, this is the main thing to learn any model. I think I have cleared all the idea of you. But although if you have any problem, please, I will try my best. As simple as